Hey guys, so I'm going to show you how this works now. This is when we have an equation with something that is unknown, but the change that is unknown happens right here before the equal sign. The last video I showed you is the change was right over on this side. So this part is a little bit confusing because the sign feels like it's in the wrong place when we go to move things around, okay? So what we're trying to say is let's say, for example, I've got, let's say I need 5 cookies and I've already bought 2. So maybe my question is, I've got 2 cookies, but I need to have 5 because I've got 5 friends coming over, but I only have 2 at home. How many cookies do I need to buy, right? Like, so I've got 2 plus how many will equal 5 in total. So what we're trying to do is as always, we're trying to isolate the letter. We want that to be all on its own. And so what we're going to do is we're going to take the number and we're going to take the sign and we're going to take it all the way to the other side of the equation. And it would not be logical. Like, let me just show you. If I had 5 and then I had a 2 and I had a plus, that wouldn't really be a logical equation because it wouldn't mean anything. I couldn't really do anything with it. So let me just rewrite. My 5 is down here. I'm going to take my plus and I'm going to put it here. But instead of a plus, it's now going to be a minus. It's going to be subtraction because the minute we move the sides, we have to change the signs, right? So addition over here becomes subtraction when it moves. So my addition sign has become right here, but instead of addition, it's now become subtraction, and my 2 is going to come right here. So I'm going to rewrite this so that it's less confusing. So now our new equation actually is the exact same stuff, but I just want to rewrite it so it's super clear. So they're saying B is the equivalent of what is 5 minus 2. So now I'm just going to go ahead and do that math because it's manageable. I'm going to go 5, 4, 3. So 5 minus 2 is 3. So B equals 3. So here's the nice thing. Let's look back at our original equation here. 2 plus B equals 5. What I'm going to do is I'm going to take my answer and I'm going to plug it into the little letter that I used to represent the unknown variable, okay? So now I'm going to say 2 plus 3 was my answer. It's going to go here. 2 plus 3 is 5. And now let's do this math. 2 plus 3 is 5. And they're saying 5 equals 5. And the minute I have that balanced, right? Think of it like a little weigh scale. We don't really use these anymore, but, you know, if we were an ancient civilization, we would use that. When it's balanced, then we know we have successfully completed that question. Here's how we handle the subtraction piece. This is I find very challenging. So what this is saying is it's saying 5 subtract something equals 1. So if I look at this over here, what it Loxy, please stop. What it's saying is that 5 minus something is 1, or 5 minus 1 is something. So what my goal is I want to take this 5 subtraction and I'm going to put it over here because it's the equivalent of saying y is the equivalent of 5 minus 1. Right? Y is this minus this. That's what y is. So that is what my equation now shows. It's trying to figure out what is that little something that's missing. So now I can say y equals 5 minus 1 is 4. But I want to make sure that I'm correct because if I had my numbers in the wrong spot, I would still get an answer, but it may not be the correct answer. So now I'm going to take my original equation, 5 minus, what I have, y equals 1. I'm going to plug the 4 into the y. So now it's 5 minus 4 equals 1. And if I do this math, 5 minus 4 is 1. And 1 equals 1. And once I have them balanced, then I know I've done it correctly. Okay, so when we have an equation in which we have multiplication now, and we still have the change as unknown, again, we're still trying to isolate this variable all on its own. We want that on its own side of the equation. So what I'm going to do is I'm going to take my 5 and my symbol, my multiplication symbol, and I'm going to put it on the other side of this equal sign. So again, we have to consult our little handy chart here. Multiplication becomes division when it moves over to the side, right? So the multiply is going to become divided by, and the 5 is going to stay right over here. So when I rewrite this, it's going to become r equals 10 divided by 5. So now I'm just going to do my actual division, and 10 divided by 5 is 2. But now I want to actually check. So I'm going to take my original question here, which is 5 times r equals 10. And I'm going to take my 2 and I'm going to substitute it for r. So I'm going to say 5 times 2 equals 10. And now I'm going to do 5 times 2 is 10. And if my result is balanced, then I know that I am correct. So there we are. Okay, the last one we're going to take a look at is division. So this, if it's saying 6 divided by m is 2, that's the equivalent of saying 6 is the combination of m times something. So if you took 6 and you divided by 2, you'd end up with m. If you took 6 and you divided by m, you'd end up with 2. So our goal now is we're going to try, and again, we always want to isolate the variable to figure out what it is. So I'm going to take the 6 divided by, and I'm going to move it right here. So I'm going to have m equals 6 divided by 2. And so now I'm going to do my math. So it's saying m equals, if 6 divided by 2 is 3, and again, I don't know if my answer is correct or not. I'm assuming it is, but it may not be. Now I have to go back and check just to make sure. So let me just zoom out a little bit. So 6 divided by m equals 2. This is our original question. We're going to plug our 3 into the m to see how this works. We're going to say 6 divided by 3 equals 2. And now I'm going to do this part of the equation. 6 divided by 3 is 2. I'm going to carry this one down. 2 is 2. When this is balanced, I know that my answer is correct, and I've got the right number.